Our first trig lesson is on angles and radian measure. So an angle is formed by two rays. So you've got one ray going out this way and another this way. The initial side is the initial ray, and then the other side, the terminal side, is created when you rotate it to a certain angle and draw the other ray. The vertex is the point where both those rays start. An angle is in standard position if its vertex is at the origin. So each of these angles are in standard position because their vertex is at the origin of the rectangular plane. Along with the initial side being along the x-axis, the positive x-axis. So as long as you're starting at the origin and going along the positive x-axis, then the angle is in standard position. Positive angles go counterclockwise from the positive x-axis, and negative angles go clockwise down from the positive x-axis. An angle is a quadrantial angle if its terminal side lies on the x or y axis. So we may have an angle that starts here and then ends there. That would be a quadrantial angle, or it could end there and be a line. That would be a quadrantial angle, or down here would also, as drawn, be quadrantial. Measuring using degrees. A circle has 360 degrees. If you've got a rectangular coordinate plane, then all the way around is 360 degrees. An acute angle is less than 90 degrees. So 90 degrees is made by, an example would be an angle made by the x and y axis, and an acute angle is less than that, so maybe like this. A right angle is one that is 90 degrees, and obtuse is greater than 90 degrees. You could also have a straight angle that's just lying along the x-axis and measuring 180 degrees. Complementary angles add to be 90 degrees, and supplementary angles add to be 180. So complementary angles would be like angle alpha and angle beta here. They would add to be 90 degrees. Supplementary angles would be like alpha and beta here. They add to be 180, which makes a straight angle. Minutes and seconds. Okay, so there's three ways that we talk about angles, and most often we talk about them in degrees or radians, but you will occasionally see them listed in minutes and seconds because of some applications that use that. So a degree can be divided into minutes by dividing by 60. Okay, 1 degree is 60 minutes. And then, just like usual, 1 minute is 60 seconds. So 1 degree would be 360 seconds. Radians. Let's read this. An angle whose vertex is at the center of the circle is called a central angle. The radian measure of any central angle of a circle is the length of the intercepted arc divided by the circle's radius. So if we look at a picture here, if we've got a circle like this green one here, then a radian is defined by the length. It says the length of the intercepted arc. So this is the intercepted arc divided by the radius. That gives us a radian. So if we want to find a radian, or a measure of an angle, and you have the length of the arc, which we call S, and you have the measure of the radius, which we call R, then you can divide S by R and get the measure of the angle. You could also find the measure of the arc just by multiplying both sides by R. And then if you had the angle and the radius, you could find the length of the arc. And we'll look at that too. So let's start with an example. A central angle in a circle of radius 12 feet intercepts an arc of length 42 feet. What is the radian measure of theta? So we said that theta is the length of the arc divided by the radius. The length of the arc is 42, the radius is 12. So we could reduce that to 21 over 6 if we wanted to leave it as a fraction, or change it to 3.5 radians. And we do need to write out the word radians here so we know what we're talking about. Okay. So let's talk about converting between angles and between degrees and radians and decimals and minutes and seconds and all that. Okay, so convert this angle, 38 degrees and 12 minutes, that's what the little asterisk there stands for. Seconds would have 2 of them. So convert this to degrees. So what we would do is we have 38 degrees already. And to change the 12 minutes to a decimal, we would take 12 and divide by 60, since there's 60 minutes in a degree. So that'd be 38 and 1/5 degrees, or changing it to a decimal, 38.2 degrees. Okay, same thing here. Let's convert this one. This one, well, we're going backwards. We've got an angle 120.45 degrees, and we want to change it to degrees, minutes, seconds. So we'll take our 120 degrees and our decimal of 0.545 will now be multiplied by 60. We're doing the opposite. And so that gives us 120 degrees and 27 minutes. To convert between degrees and radians, we have to take into the account that pi radians equals 180 degrees. And so that makes it pretty simple for us to convert between the two. So to convert from degrees to radians, we multiply by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. And so you'll see what I mean here. So we've got 60 degrees. Now, let's say you forgot and you don't know which way to go. If we multiply by 180 divided by pi, then we get a pi on the bottom. That's not going to work, okay? So what we have to multiply by is pi over 180. And that's going to change it to a radian for us in pi, in terms of pi. So 60 divided by 180 is 1/3. So this is the same as pi over 3. You're going to see this stuff a lot. 60 degrees is the same as pi over 3 radians. That's one of our special angles. So let's change these from degrees to radians. Same deal. 270 times pi over 180. And you just divide. And we usually leave these as fractions. This one would be 3 pi over 2. For negative 300, also multiply by pi divided by 180. And this time, 300 over 180 simplifies to be 5/3. So this would be negative 5 pi over 3. Okay, let's go the other way. Pi over 4 radians, we want to change it to degrees. Again, let's look at this. If we multiply by pi over 180, it's not doing us any good. While if we multiply by 180 over pi, that gets rid of our pi, which is what we want to do when we change back to degrees. And 180 divided by 4 is 45 degrees. Negative 4 pi over 3. So multiply by 180 over pi. So we'll do 4 times 180 and divide by 3. We get negative 240 degrees. And last, 6 radians. This time we don't have a pi, but that's okay. Multiply by 180 divided by pi. That's the same thing as 1080 divided by pi, if we wanted to leave it in exact terms. Or if we want to change it to decimal, just put that in your calculator. We get 343.77 degrees approximately. Then how do we draw angles? So if we want to draw an angle in degrees, you've probably done that before. That's pretty straightforward. In radians, we have to learn a few new things here. So straight, if we've got a 90-degree angle, let's go over to this picture over here. Here's a 90-degree angle in this last picture. That is pi over 2. We talked about the fact that 180 degrees makes a straight angle, a line. We're looking at the third picture right now. And 180 degrees is the same as pi radians. So that's why a straight line would also be pi radians. And why 90 degrees, looking at the fourth picture again, would be pi divided by 2. If we're going all the way around, that's 2 pi, okay? 1 pi here, and then keep going. We've added another pi. There's 2 pi radians, or 360 degrees. Talking about revolutions, all the way around is 1 revolution because you've revolved, I guess, around the whole circle. If you go halfway, that's half a revolution. Or if you go 90 degrees or pi over 2, that's 1/4 of a revolution. And then let's look at this second picture. What if we go all the way past pi, another pi over 2? If you take pi over 2 and add pi to it, get a common denominator, all that, you get 3 pi over 2. So 3/4 of a revolution is 3 pi over 2 radians. Or 90 plus 90 plus 90 is 270 degrees. So let's draw some angles here. When we draw angles, we're always going to put the initial, we'll start with the vertex at the origin, and we're going to put the initial side on the positive x-axis. This is negative pi over 4. So negative means we're going to go clockwise. We're going to go down, okay? So we already know we're going down with this. So let's think about how far we would go. If we go all the way to here, that would be pi over 2, right? Negative pi over 2. Pi over 4 would be halfway between 0 and pi over 2. So pi over 4 is approximately right in the middle. And this is our negative pi over 4. Three pi over 4. Where would that be? Okay, again, put your vertex at the origin and your initial side along the positive x-axis. So 1 pi over 4 would go and stop right there. 2 pi over 4 would get us to pi over 2. 2 pi over 4 reduces to pi over 2. Another pi over 4 gets us to 3 pi over 4. You see how I count that? 1, 2, 3. So there's 3 pi over 4. It's about halfway, or it is halfway between pi over 2 and pi. Negative 7 pi over 4. Okay, again, we've talked about pi over 4 is halfway. Okay, so, or halfway between 0 and a pi over 2. So negative pi over 4, 7 pi over 4, we're just going to go pi over 4 7 times, and since it's negative, then we're going down. So here's 1, 2, 3, 4, 5, 6, 7. So this angle, not going from here to here, but all the way around, is 7 pi over 4. And then example 8 wants us to draw 13 pi over 4. If we go back to example 7, let's talk about this for just a second. You notice that this angle is the same as the angle pi over 4, okay? Or at least its terminal side ends up in the same spot. So we'll be talking about that more in the future. And 13 pi over 4, so we just count 13 times. 1, 2, 3, 4, 5, 6, 7, 8, keep going, 9, 10, 11, 12, 13. So we end up here. And so all the way around to that terminal side, oh, I forgot my initial side, is 13 pi over 4. And that concludes the first part of our first section